Hi, today we're going to start talking about using dplyr verbs to do things like join together data sets. So this is called relational data, and we will look at different ways to add variables to one tibble by matching observations, or filter observations based on whether they match another, or to use set operations. And the reference for this is going to be the R for Data Science book that's available online with the relational data chapter. There's also a cheat sheet available through RStudio that you can use. You would want to read along with these lecture notes, which are available on GitHub, and I can give you the link for those as well. We're going to use the New York City Flights 13 data set. So I'm going to start with just my usual library of tidyverse. And to library the New York City Flights 13 dataset. Before I start on the actual dplyr verbs that we're going to use for these, I want to talk for just a second about how you might find what data sets are in a package. So for instance, if I wanted to find the data sets in the New York City Flights 13 package, that's going to show, however, in the viewer. So let me So if you repeat what I just did, you will see these pop up in the viewer. But if I want to actually see the results, I can do it this way. So this is a way to see the different data sets that are in a given package. If you want to see the functions that are in a package, I could do something like this and look at dplyr functions, and that'll show all the functions that are in a given package. Now looking at, let me scroll back up here. Well, I can't do that. Let's see, too far back. Let's look at just the data sets that are in here, because I might want to look at more than just the flights data, which is what I typically have looked at. So if I want to look at, for instance, what's in the airlines, oh, that might be handy. I might want to add that to my existing data set. I could try what's in flights. We've already seen that quite a bit. Let's see what's in planes. Oh, that might be interesting. If I'm looking at delays by plane type, and maybe I even want to look at the weather at the different airports if I'm looking at what caused a delay. Now we're going to talk for a minute about how do you identify a unique observation in a table. Those are going to be what we call the keys. So these are going to be things that we use to identify uniquely an observation or to match up data between data sets. For instance, if we look at the planes data set, and we just look at, say, the tail number, it looks like those are all unique qualifiers, but just to be sure, we will follow that with a filter and see if there's any that occur more than one time. There are not. We get an empty tibble, so this means we have a unique identifier. So in the flights tibble, what do you think would be the primary key? We could try, let's see, maybe the year, the month, the day, and maybe the flight number, right? And let's see if there's any of those, if we get more than one. Oops, but I did flight instead of flights. Let me go back. Oh, we have some. Well, we must have the same flight number that did multiple flights out of a city on the same day. We will try again using tail number and see if that reduces the number. So here again, we're going to check. We still have the same tail number. Wonder if we did that with both of them, we could keep trying combinations. Another thing we can do is what's called a surrogate key, where we add a row number. Then with the row number then becomes our key that we could use to distinguish each flight. Now, I'm going to have you, for your exercise on this section, identify the primary keys in 3 different data sets. So you're going to look at the batting data set out of the layman package, the baby names data set out of the baby names package, and the Atmos data set out of the NASA weather data package. And you're going to identify primary keys for each of those data sets in the same manner I did here, with checking the count for those combinations and seeing if you got more than one. The other exercise you're going to do out of this set is to establish the relationship between the batting, the master, and the salaries tables in the layman package. What are the keys for each and how do they relate to each other?